Okay, now we're on to the next page. Here we go. How many license plates are possible if they must consist of 2 letters followed by 3 non-zero digits? So you're going to make a license plate. It has 2 letters. This is a letter and this is a letter. And then 3 non-zero digits. So we're going to have a number, a number, and a number. Digits mean numbers. Okay, so they don't give me any restrictions at all in problem number 9, except I have to have 2 letters followed by 3 non-zero digits. How many choices do I have for the first letter? How many letters are there in the alphabet? Okay, there are some things. Yeah, 26. There are just certain things that people of your age are supposed to know, and one of those is there are 26 letters in the alphabet. You all know your ABCs, so count them if you're unsure. 26 letters. So I sit down to make the license plate. I have 26 choices for that first spot. Now, I need a letter here. Be careful. There are still 26 choices because the problem doesn't tell me that I can't repeat. It is possible in this scenario to have an M and an M. So I have 26 choices for this spot and 26 for this spot. Now, how many non-zero digits are there to choose from? How many options do I have for this blank?
9.
9, yep. There are 10 digits altogether, but one of them is 0. So you only have 9 that aren't 0. And again, you have 9 here and 9 here because it's possible to use the numbers more than once. You could use 7, 7, 8, for example. There's no restriction in the problem. So you would just take, all these are multiplied. So 26 times 26 times 9 times 9 times 9. So 492,804. That's how many license plates would be possible given this scenario. Now, number 10 has exactly the same situation, but now I can't repeat. So I still need a letter and a letter followed by 3 numbers, but nothing can repeat. Can anybody set that one up for me?
26 times 25 times 9 times 8 times 7.
Beautiful, beautiful, beautiful. Nothing can repeat. So you got all your choices for the first blank, but now you've only got 25 choices for your second blank because you can't use the one you used here. Does that make sense to everybody? And the same with the numbers. You have all 9 choices here, but now you only have 8 because you've used 1, and now you only have 7 because you've used 2. And those are all multiplied together. And that is 327, 600. All right. You've all listened to the radio or watched TV, so you know these stations have what are called call signs. So, like I like to watch Channel 13 News, WTHR, and sometimes I listen to WIBC on the radio. Those are the call letters, call signs. So this says, how many 4-letter call signs are possible if every letter is allowed. So no restrictions, you're starting your own radio station. How many possibilities are there for you to make a call sign? Any ideas?
$26, like all the way across.
Exactly. Very good, Gabe. 26, 26, 26, 26. Because there are 26 possibilities and there's no restrictions. So you could pick from 26 letters here, from the same 26, and so on and so on. So that would be a lot. 4, 5, 6. 4, 5, 6, 9, 7, 6. Call signs. Now, let's look at the next one. All right, so that was number 11. Right now, 12, I'm still picking 4. But this time it says, no letter may be repeated. What do you think about that? I can't repeat a letter.
Is it 26 times 25 times 24 times 23?
It absolutely is. Very, very good. Because whatever letter you picked first, you can't pick here. So now you're down to 25. But now you've picked 2, so you're down to 24, and so on. I'm going to multiply all those together. And I get 358, 800. All right, now number 13. How many are possible if no vowels are allowed? So you're still making a 4-letter call sign, and you can use any letter you want except a vowel.
21 to the 4th power.
Yes, indeed. Very good. 21 times 21 times 21 times 21. Remember, there are 5 letters generally considered vowels. A, E, I, O, and U. We're not getting any debates. Those are the 5 that are considered vowels. So since we have 26 altogether and 5 of them are vowels, then there must be 21 consonants. So that's 194,481. And finally, 14, no vowels and no repetition. No vowels and no repetition. What do you think about that? No repetition means you can't use a letter you've already used. You can't repeat letters.
21, 20, 19, 18.
Yep, you've got it. Perfect, perfect, perfect. If you're not allowed to repeat, then you can't use the same letters over again. That's 143. Does those 4 problems were basically the same problem. They just had different details. Does anyone have a question about any of those 4? We see the difference there between them? Okay, so let's go on to 15. A baseball team has 9 starters. How many different batting orders are possible? So we're assuming no restrictions. We're assuming anybody can bat anywhere. How many orders are possible? Any thoughts?
Is it 9 to the 9th power?
No, but you're on the right track. Think about this for a minute, Gabe. Here are my 9 spots, right? I have to turn in my batting order. So I have 9 choices for my first spot, but I don't have 9 for the second spot. How many choices do I have for the second spot?
8.
Yeah, and then 7, and then so on. So that is 9 factorial. Kids, I'm going to say it one more time. When you arrange 9 things in a row, it's 9 factorial. And I know it doesn't say I'm arranging these players in a row, but isn't lining them up for a batting order, isn't that arranging them in a row basically? That's 9 factorial. Every time, 9 things in a row is going to be 9 factorial. Now, what if the pitcher has to bat last? Now, I want you to think about that for a second. If the pitcher has to bat last, then how many choices do I have for this blank right here? This is my batting order. This is the last guy. Don't I have just one choice for that? That's the pitcher. Now, how many guys are left?
8.
8. So now I've got 8 choices here. 7, 6, 5, 4, 3, 2, 1. Basically, guys and girls, if you are taking the pitcher out and saying he's got to be at the end, then aren't you really just arranging the other 8? So it's 8 factorial. That would amount to 8 factorial if you multiplied it all together. Now, one more batting order problem, number 17. The pitcher bats last and the best hitter bats third. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's one choice for the last spot, that's the pitcher, and there's one choice for the third spot, that's the best hitter. How many choices are left then to start filling in the rest of the order?
7.
Yep. And then 6. And then 5, 4, 3, 2, 1. If they tell you that a particular person has to be somewhere, then you don't have choices for that spot. That spot's filled. There's one guy sitting there, and there's one guy sitting here. You have choices for the other spots. But since you've already taken 2 out of the mix, you only have 7 left over to arrange. Okay? All right, let's look at the next one. It's a little bit different. See if we can figure it out. Okay, so in number 18, we are going to make some numbers. And we are only allowed to use the digits 1, 2, 3, 4, 5, 6. So in other words, we're going to make numbers that look like 34, 356, 266, and so on and so on and so on. Okay? We're going to say, how many of these can we make? They can be 1-digit numbers, or they can be 2-digit numbers, or they can be 3-digit numbers. So this is our pool of numbers that we're allowed to use. There are 6 numbers possible. So you have 6 numbers to choose from. How many 1-digit numbers can you make from that list right there?
6.
Bingo. There they are. There are the 6 1-digit numbers. That's it. So you can only make 6 1-digit numbers. All right, what about 2-digit numbers? You have to use those numbers So how many choices do I have? 6 for the first one and 6 for the second one. So there's 36 two-digit numbers. If you don't believe me, you can write them all out. Things like 12, 11, 12, 13, 14, 15, 16, 21, 22, 23, 24, 25, 26, and so on and so on and so on. There's 36 of them. How many three-digit numbers? $216, 6 choices, 6 choices, 6 choices. So those numbers would look like 1, 2, 3, 2, 2, 3, 3, 3, 3, 3, 3, 3, 3, just 3 threes. Any three-digit number that you use those digits for. Now, does anybody have a question so far? Because we're not quite done with the problem.
We just write all those numbers for answers?
Okay, now we need to get our final answer. You're right, Gabe. Listen to me carefully. In this situation, we are picking one-digit numbers or 2 digits or 3-digit numbers. Whenever you have this or this or this, you add. So the final answer, Gabe and everybody else, will be these 3 numbers added up. Now that makes sense, because if you can make 6 of these and 36 of these and 216 of these, how many can you make all together? That's this. So the final answer to the problem, how many you can make all together, is 258. So there are 258 numbers that you can make all together. Whenever you have this many ways to do it or this many ways to do it, you have to add. To find the total, you're going to add. All right, number 19. Basically what this problem is saying is how many ways can I arrange the letters of the word Chevy? You know this. You know the answer. I've talked about it 3 times. How many ways can we arrange the letters of the word Chevy?
5 factorial?
Yes, 5 factorial. Because there are 5 letters and I'm arranging them in a row. So the answer is 5 factorial or 120. All right, how about the letters of the word Precal?
6 factorial, 720.
6 factorial, which is 720. Very, very good. Why is number 19 5 factorial and number 20 is 6 factorial? Why is that?
Depending on how many letters are in the word.
Exactly. Exactly. Super. Number 21. How many social security numbers are possible if all arrangements are possible? So there are no restrictions in this problem. I don't know in reality if there are restrictions on social security numbers. That would be something you could Google. But we're assuming no restrictions, so anything goes. So your social security number looks like 3 digits, and then 2 digits, and then 4 digits, right? Everybody familiar with that, your social security number? Now, if every single option is possible, how many choices would I have for this blank right here?
5.
Actually, 10, because there are 10 numbers, and we are allowing every single possibility. Now again, I don't know if this is realistic or not. I don't know what the real rules are, but we're just going with what it says in the problem. All arrangements are possible. So you have 0 through 9. There are 10 digits. And then 10 here, and 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 here. So the answer would be a big number. Lots of zeros. Let's see. 1, 2. I got a billion. Did you get a billion? 10 to the 9th. A billion social security numbers. How many telephone numbers are possible in the 317 area code? So most of you probably have a 317, and then you have your phone number. So we're saying got to use the 317 area code. Assuming that there are no restrictions, and again, I don't know how realistic that is, but let's just go with no restrictions. How many do we have? Does that look okay to everybody? And that would include every single possible combination. So that would include 0, 0, 0, 0, 0, which again, I don't know if that's realistic, but that would be the maximum number of phone numbers, which is 10 million. Do you remember not long ago they added an area code to Indiana? It's been a while back, so you may have been too little. But they have to add area codes because you run out of phone numbers. So every area code has 10 million numbers, but once you've got 10 million phones registered in 317, you need a new area code, or else people start doubling up on phone numbers, which isn't a good thing. All right, 23. How many 11-letter words can be formed from the letters of the word pre-calculus? Well, we already did a problem like this. Anybody want to take a guess?
11 factorial.
That is a magnificent guess. And that is exactly where we're going to start with this problem. But that is not, make sure I spelled it right, pre-calculus, okay. That's 11 factorial because there are 11 letters in the word. But what is different, we did Chevy, we did pre-cal, and now we're doing pre-calculus. What is the difference between the Chevy and the pre-cal we did first and this guy?
Letters repeating.
Exactly. So how you handle what we call repetition. You have repeated letters. You have 2 C's. Let's see, what else do I have? I have 2 L's. And I have 2 U's. Is that all my repeats? When you have identical objects, when you have repetition, they're called indistinguishable repetitions, then you must take your total, which is 11 factorial, because there are 11 letters, and divide by each duplicate factorial. So my C's will be 2 factorial, because there's 2 of them. My L's will be 2 factorial, because there's 2 of them. And my U's will be 2 factorial because there's 2 of them. So you divide by each letter factorial, each duplicate letter factorial. Now, when you type this into your calculator, because there are lots of things in the denominator, more than one thing in the denominator, please put it in parentheses. So we'll go to our calculator, we'll do 11, math, we'll go across the probability and down to factorial. So 11 factorial divided by parentheses 2 math across the probability down to factorial, and then another 2 math across the probability down to factorial, and then 2 math across the probability and down to factorial. If you typed it in correctly, you should get 4,989,600 words that can be formed from those letters. Does anyone have a question about that? All right, let's do number 24 then. It's exactly the same thing, only the word is Mississippi. Mississippi. How many ways can we arrange those letters? So what's the first thing we have to do?
11.
Okay, so the first thing you have to do is count the letters. How many do you have? And he says there's 11, let's see, 4. Yep, he's right, there's 11 of them. But I noticed when I was writing the word that some of them repeat. So let's see, it looks like I have 1, 2, 3, 4 I's, so that's a 4 factorial. However many repetitions you have, it's that factorial. And then it looks like I also have 4 S's. So that's another 4 factorial. And then I have 2 P's. So that's a 2 factorial. So again, when you type this in, because there's more than one thing in the denominator, you've got to put it in parentheses. Always, 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 when you are dividing by more than one thing, put it in parentheses. So 11, math, across the prob and down to factorial. That's 11 factorial. Divided by parentheses. And before you complain about having to press all these buttons, remember Mrs. Ford had to do all this by hand when she took this class. There were no calculators, we did it by hand. If you got 34,650, you are right. Does anyone have a question about that? Okay. Does anybody know how many kids are at Cathedral?
Just under 1,200,
All right.
I think.
Yeah, I think it's a little lower than that. Let's go with 1,100, just for argument's sake. We'll say there's 1,100 students in our school, okay? How do I know with absolute 100% certainty that somebody has to have the same first and last initial? How do I know that? Absolutely. Guaranteed.
Is it because since there's 26 letters, like, I don't know, like, you have 1,100 chances that it, like, matches up. I don't know how to say it.
Okay, well, you're right on target. If I look at your first and your last initial, assuming that there's all kinds of different kinds of names, so every letter could be your first initial, and every letter could be your second initial. So if we're only picking 2 initials, first and last, the number of possible arrangements is 676. If there are only 676 combinations, but there's 1,100 kids, doesn't that mean some of them have to match? It doesn't mean that someone matches you. It just means some of these people have to match each other because there's only 676 combinations possible. And that includes everything like ZZ and XX. All those are considered. So somebody's going to match. Does that make sense to you? All right, how many ways can a club with 20 members choose a president and a vice president? And then question B, this is number 26. Question B says, in how many ways can they choose a 2-person governing council? All right, guys, this is our first kind of big deal here. We need to talk about this. Read number 26. Read question A, read question B. Are they the same question, just worded differently, or are they 2 different questions? What do you think?
I think they're the same, worded differently.
Okay, anybody else want to comment? All right, so let's talk about this for a minute. Let's suppose that I am picking a president and a vice president. I pick Gabe for president and David for vice president. Is that different than if I pick David for president and Gabe for vice president? Yeah, it is. In other words, in question 26A, the order that I pick matters. If I am choosing a president and a vice president, I am assigning specific tasks, then the order I choose matters. But let's say I'm just picking a governing council, and I'm going to pick Scruggo and JP. If I am picking a governing council, does it matter if I pick Scruggo and JP or if I pick JP and Scruggo? Does the order matter if they're just going to be a 2-person council? No, it doesn't. When you are choosing items and order matters, we have what we call a perm mutation. In this problem, we would have 20 people chosen 2 at a time. Order matters. It's a permutation, 20 people taken 2 at a time. That can be written in 2 different ways. I'm going to use both notations periodically to keep you comfortable. But what this says to me is you have 20 people, you are choosing 2, and order matters. In your calculator, I want you to type the number 20. Then I want you to go back to that same math button and go across to prob. And do you see a button that says NPR? Press it. And then type 2. So we put the 20 in first. Then we found our NPR button. Then we press 2. And the answer is 380. There are 380 ways that you can pick 2 people out of 20 and order matters. 26B, order doesn't matter. This is called a combination. So you have 20 people, you are picking 2 of them, and order doesn't matter. That's a C problem, a combination problem. That can also be written like this. On your calculator, press 20. Go to your math button and across to prob. Do you see your NCR button? Press it, press 2, and it's 190. This will take some practice, but basically you have to just read the problem and decide if order matters or not. So we're going to finish up with number 27. Again, you have an A and a B. Both problems involve 13 kids and picking 4. 13 kids picking 4. One of them is a P problem, in other words, order matters. And one of them is a C problem, order doesn't matter. Anybody want to take a guess if A is order or no order? Does order matter in number 27A?
No.
No. Order does not matter. If you are picking a leadership team, if I pick Miriam, Lindsay, Clara, and Kennedy, no one cares what order I pick them. They all got picked. So A is 13, C4. 13 total people, your total people go first. The C, because order didn't matter, and I'm choosing 4. So 13, math, across to prob, down to NCR, and then 4. You should have gotten 715. In 27B, does order matter? Yes, because the first person I pick is going to be the president. And the second person I pick is going to be the vice president. If you are assigning specific tasks, specific roles, specific jobs, order matters. Order matters. So B will be 13, P4. Remember, the P stands for permutation, and permutation means order matters. So 13, math, prob, P, whoops. And I'm picking 4. I got 17,160. Okay? Well, we just wrapped up 9.1, so I'd like you to take a stab at that homework. That homework will be due on Wednesday, and I would hope that if you had questions about it, you would come to office hours on Wednesday morning. Anybody have any questions for me? All right, have a great day, guys. See you later.
Thanks, Miss Ford.
Bye-bye.
Adios.
Adios. Oh, shoot.